Good day all. Welcome to Datalytics from theory to practice. Today we'll be looking at leave-out one cross-validation misclassification error. You should expect to be able to solve problem on Loocv misclassification error. We have earlier discussed in earlier videos, we have discussed the use of cross-validation and KNN, K nearest neighbors. So let's look at an example. Example 1 says, consider the K nearest neighbors approach using a cleaner distance on the dataset shown in figure 1. What are the Loocv errors for the following cases? Briefly justify your answer. This question was adapted from the University of London machine learning exam. Now we can see on the left hand side of figure 1, we can see plus, plus, minus, plus, plus. On the right hand side, we have 5 minuses. That is, we have 5 minus signs, as the case may be. Now we are looking at, well, we want to find the classification errors using one nearest neighbor. Right? For the one nearest neighbor, we can see that in figure 1, the left hand side is actually having plus, plus, minus, plus, plus. That is, negative is close to immediate plus. The same, a plus is close immediately to what? To a negative. So, which means that is 1 out of the whole 5 now is actually misclassified because you're talking about one nearest neighbor. 1 to 1, 1 to 1. So, and that is it. So now the one on the right hand side, on the other hand, it has all positive, all negative. As we can see, all negative. The one here, they are all negative. While the one here, we can see that for every plus, there's a minus close next to it. So that's what we're talking about. One nearest neighbor. So in that case, we can deduce that the misclassification error due to one nearest neighbor is 5 out of 10. Now let's look at 3 nearest neighbors. Now for 3 nearest neighbors, now we look at plus plus, the next is a minus, which is just 1. Also for the lower part of this, one here, we have minus plus plus, minus plus plus. So based on that, it is 1 out of 5 here. So when we pull the two together, it is what? 1 out of 10. So the misclassification error based on 3 nearest neighbors is 1 over 10. That is the solution. Let's go to the next example. Next example. Now, the next example says, consider the K nearest neighbors classification using the cleaner distance on the data set shown in figure 2. Now look at this data displayed here. Sketch the one nearest neighbor decision boundary and identify the regions classified as plus and minus respectively. 2. What is Loocv error when using 3 nearest neighbors? 3. What is Loocv when using 5 nearest neighbors? So let's look at the solution. Now we are going to look at the solution here now. Now the solution here is the decision boundary. Look at the sketch now. The positive side is actually is for the positive, that is the gray side is for the positive, and the white is for the negative. We can see the boundary. So anywhere we see negative is actually talking about the white region, while the gray is about the positive. Now, these have been separated into the respective region. Now, this is what we are saying, as we can see here. As we can see here, this region is talking about the white part is only for the negative, while the gray is for the positive. So we can see how the boundary is being provided. Okay, so now let's look at the first questions. The first question there that has to do with, says, what is the LOCV when using three nearest neighbors? Now, looking at three nearest neighbors, for every negative, 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 there's a positive associated with it. And for every positive, three positives, there's one negative close to it. In that case, and we are dealing with what? LOCV, leave out one cross-validation. So in that case, 1 out of 4 is misclassified, which is same thing as 2/8. Right? 1 out of 4 is misclassified based on the data provided in this figure 2. Now that is for the 3 nearest neighbors. Now for the 5 nearest neighbors, 5, we can see that we cannot have 5 positive or plus sign grouped together without having a negative close to it. And as a matter of fact, here we have 3. So if you pull the two together, for us to have 5, we must, for us to be able to have 5 nearest neighbors, we must have 5 points. So let's pull it together. Now we can see that there is no case where we can actually have 5 as a whole without having an interruption of sign. So by implication, 8/8 is misclassified, which is what? 1. Now let's look at our exercise. Look at this picture. This picture clearly, we have 4 people here, 3 in uniform, 1 not in uniform. So the question now says, what is the LOCV error when using 3 nearest neighbors based on whether or not the participant wears a uniform? So we can see that this actually is likened to the previous problems we have solved, and you can use that knowledge to solve this particular question. So I'll be expecting your answer in the comment section. So go to the comment section, make your comments, and don't forget to subscribe if you have not, and turn on your notification button for more videos. Thank you very much. Don't forget, as I said earlier, this is machine learning class, and there are more videos that are going to be coming. Subscribe to Datalytics. Thank you for choosing Datalytics, and let's watch out for more videos. So I'll be expecting your answers in the comment section. Thank you.